Today we're going to talk about points on the coordinate plane, which is found in section 5.1 of your BJU Press Algebra 1 textbook. So let's begin with graphing some points on a horizontal number line. So for a horizontal number line, it's going to go from left to right. So -5 would be here, 0 would be there, and 3.5 would be between 3 and 4. Well, what if we had to graph points on a vertical number line? So a vertical number line is going to look like the horizontal. It's just going to be rotated up and down, where your positive numbers are going up and your negative numbers are going down, right? And so it almost looks like a thermometer almost. So if you were to put the 2, it would be right there. -4/3 is going to be between -1 and -2, so right about there. So let's talk about some definitions. Our first definition is an ordered pair. So an ordered pair is a pair of numbers. That is what an ordered pair is. Usually when we're talking about the coordinate plane, our ordered pairs are going to be an x value and a y value, an x coordinate and a y coordinate. And an ordered pair is going to describe a point in the coordinate plane. Okay, so it's going to describe a point on the coordinate plane. This word right here, this is just the Cartesian coordinate plane. So this is kind of the formal name of our coordinate plane that we use. It's from the person who created it, so it's kind of math history right there. But you can just simply call it the coordinate plane, and that will be fine. So the two symbols in an ordered pair are called coordinates. Coordinates. So you might have heard that word before when you're if you've heard anyone who is trying to give directions and they're using like an atlas, or if you're on an airplane or a boat, you have coordinates. It's kind of like a grid system. So you have an x coordinate and a y coordinate. So the x is the horizontal coordinate and the y is the vertical coordinate. So you also have these things called quadrants. So quadrants are like you take the coordinate plane and you divide it into fourths, right? Because quad means 4. So the quadrants are the pieces that are divided, in the sections. Those are called the coordinates. So there's going to be 4 of them. So you start at the top right, that's quadrant 1, and then you go counterclockwise. So there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Notice how we use Roman numerals to indicate those quadrants. So the x-axis is the horizontal number line on our coordinate plane, and the y-axis is the vertical number line in the plane. And the origin is the point 0, 0, and those are where those axes intersect. So to plot points, you're going to do the horizontal distance first, right, the x, and then you'll do the vertical distance, or the y, second. So you can think about it this a couple of ways. First, about alphabetical, x becomes before y, so x is horizontal and then y is vertical. And then you can also think that you have to walk before you can jump up and down. So you're going to go horizontal before you go up and down. The ordered pairs are, alphabetical, so they go x and y, right? So the x coordinate has a formal name. It's here, and it is the first coordinate of the ordered pair. And then the y coordinate, which has a formal name as well, ordinate, is the second coordinate of the ordered pair. So let's say we want to graph these points. The coordinate 2, 1 is going to be horizontally 2 and then vertically 1. So it should be, we're going to go over 2 and up 1. And that's going to be the coordinate 2, 1. For the coordinate -3, 4, you're going to go left 3 and then up 4. And that's the coordinate -3, 4. And then for 0, 5, you're not going to go left or right because it's 0, but then you're going to go -5, so you'll go down 5. So here are the steps to plotting points. Step 1, you move x units right or left from the origin, depending on what your first coordinate is. And then from that position, you're going to move y units up or down, depending on what your y coordinate is. and then you're going to graph the point and label it with its coordinates. So you're going to put a dot where that point is and then label it with the ordered pair. Okay, if they give you a letter, for the ordered pair, instead of writing the ordered pair, you're actually going to write the letter that represents the ordered pair. So D, for example, like if we wanted to say what is the coordinate for point D? Well, to get to D, we had to go to the left 1, so our x coordinate is -1, and then we had to go down 2, so our y coordinate is -2. And it's in quadrant 3 because if quadrant 1 is the top right, so it goes quadrant 1, quadrant 2, and then quadrant 3. Point E, you had to go 3 to the left, so that's -3 for your x coordinate, and then you had to go up 5, so that's 5 for your y coordinate, and that's in quadrant 2. And then point F, you had to go to the right 1, 2, 3, 4, so your x coordinate is 4. You didn't have to go up and down though, so your y coordinate is going to be 0. And this is actually not in a quadrant, it's actually going to be on the x-axis, right? It's on the x-axis. So the next thing I want to talk to you about is a scatter plot. So a scatter plot is just whenever you plot a bunch of points that represent information, kind of like from a word problem. So if you plot a whole bunch of points, you can have an idea that of what the relationship between those two sets of numbers are. So let's say you're doing time versus grade, so time studied versus grade. So the more time you study, or the bigger your x value gets, the higher your grade should be, or higher your y value should get. So that's what the scatter plot is used for. So if you look at example 3 in your BJU textbook, something that you need to be able to do on your scatter plots is adjust the scale of the axes and their intersection to fit the data. So for example, like if you know that you're dealing with something that the first number is going to be 200, you don't want to start your scale at 0 because then you're not going to have a point for 200 units. So you don't want to do that. And then also, if your numbers are really, really big and the difference between them are in the hundreds, instead of counting by ones, like 1, 2, 3, 4, 5, 6, 7, you might count by tens, like go 10, 20, 30, 40, 50, 60. So you're going to have to adjust the scale of the axes and their intersection to fit the data. So for a scatter plot, you'll plot your ordered pairs, and then you can take a look at what that scatter plot says. So notice that the scatter plot kind of goes upwards. We'll say that this is a positive correlation because it's going upwards, right? It's an upwards trend, so we'll say it's positive. If it was going downwards, we would say it was negative. So it's positive, and then if you notice, all of our points that got plotted, they're really close together. So we'll say that's a strong correlation. So correlation, they're strong, they're really close together, so they almost make a line. So we'll say that's a strong positive correlation. If the points were kind of loose and not really together, we would say that was a weak. And then if we couldn't tell if it was going positive or negative, if the points were all over the place, we would say there was no correlation, like they didn't make a trend, right? So the whole point of the scatter plot is to be able to tell what the relationship. So because this is going positive and this is comparing the height and the weight, you can say that as the height increases, the weight increases. So you can get a relationship between the two numbers. And then notice the scale. On your x-axis, you start at 57 and you're counting by ones. But on the y-axis, you start at 80 and you're counting by tens. That's completely okay to do that. So just so you know, that's an example of adjusting the scale so that way all your points fit on the graph. So the graph rises from left to right, so that means it's positive correlation. All right, go ahead and try some problems on your own.